Good morning and welcome to this webinar, which is organized by the environmental agencies in Norway and Sweden together with the Norwegian University of Science and Technology. In this webinar on how to deal with increasing the resource use, you will receive the main messages of the International Resource Panel's flagship report, Global Resource Outlook 2024. In the following order, you will hear Janusz Potocznik, co-chair of the International Resource Panel, partner at Systemic, and former European Commissioner for the Environment. Marianne Gjørv at the Norwegian Environmental Agency, Norway's representative in the International Resource Panel Steering Committee. And then the three panel members, Edgar Hertvik at Norwegian University of Science and Technology, Eva Primer at the Finnish Environmental Institute, and Anders Wikman, member of the Royal Swedish Academy of Sciences. I'm Daniel Berlin at the Swedish Environmental Protection Agency, and I'm Sweden's representative in the International Resource Panel Steering Committee. Before we get started, I want to mention two more things. One, this webinar is being recorded and will be made available after this webinar on the Norwegian Environment Agency's website. Second, since we only have 1 hour, there will be no room for questions at the end of the webinar. With that said, let's get the webinar started.
Dear friends, last decade's attention by policymakers was mainly given to the climate change, with good reasons, but with limited success. Global CO2 emissions were in 2023 higher than ever. Global surface temperature already increased to 1.5 degrees Celsius above pre-industrial level, the upper limit we have set to ourselves. Surprisingly, I do not hear many really panicking. Most worrying, fossil fuel subsidies topped $7 trillion or 7.1% of GDP in 2022, the highest yearly figure ever. So we should get ready. It will likely get worse. We are crossing 6 out of 9 planetary boundaries, which is obviously pushing us out of the safe operating space in which our societies have evolved. In a scientific work recently published by authors of The Behavioral Crisis Driving Ecological Overshoot, they claim that climate breakdown is a symptom of ecological overshoot, which in turn is caused by the deliberate exploitation of human behavior. The material footprint is dangerously under-discussed, where discussion of climate often centers on carbon emissions. A focus on overshoot highlights the material usage, waste output, and growth of human society, all of which affect the Earth biosphere. In short, the main problem in our growing societies, often overlooked, are our consumption and production patterns designed by the industrial world, which are wasteful and unjust. If we do not change them, we will face increasingly severe environmental impacts while not having even basic human needs met. Global Resource Outlook 24, recently released by International Resource Panel, is clearly identifying essential drivers and pressures we should address. We need a fundamental shift, systemic shift in how we use resources, away from wasteful, linear production and consumption systems towards circular, resource-efficient societies optimizing well-being for all. To avoid severe environmental impacts, breaking the links between ever-increasing resource use and economic development, so-called decoupling of economic and well-being growth from resource use and environmental impacts, it's a must. The wealthiest benefit most from resource use and are also responsible for most environmental impacts. High-income countries use 6 times more materials per capita and are responsible for 10 times more climate impacts per capita than low-income countries. Meanwhile, many low-income countries still do not use enough material to even meet basic human needs. Efforts to rapidly cut greenhouse gas emissions need to consider these stark inequalities, both between and within countries, and be based on principles of fairness. This is illustrated by the concept of a fair consumption space, which stresses the need to curb wasteful overconsumption while ensuring consumption opportunities needed for meeting basic needs, decent living standards, and human dignity. Without policies aiming at lifestyle changes in high-income countries, meeting the Paris Agreement will be close to impossible. In summary, climate change could only be effectively addressed by combining currently prevailing supply-side solutions linked to energy decarbonization with demand-side solutions related to consumption, behavioral change including decoupling, and nature-based solutions, exploiting the potential of ecosystem services and environmental sinks. IRP is proposing to focus our attention on most resource-intensive provisioning systems, built environment, mobility, food and energy, which represent 90% of global material demand. Focusing on human needs would allow and incentivize cross-sector innovation and also shifts to more future-fit business models. The future will be green, or there will be no future.
I'm Marianne Gjørv. I work with international cooperation in the Norwegian Environment Agency. I will give some key messages from the International Resource Panel's report, Global Resources Outlook 2024. The report was launched at the UN Environment Assembly in Nairobi in March, where all the environment ministers met. The report gives status and trends in the world's resource use. It describes environmental consequences from resource use, and it presents possible resource-efficient and circular solutions in the fields of the built environment, mobility, food, and energy. Here you see the headline in The Guardian about Global Resources Outlook 2024. If we don't change the way resources are used, extraction of raw materials could rise by 60% by 2060. The report proposes action to reduce overall demand rather than simply increasing green production. The report also hit the headlines in Norway. The Norwegian broadcasting company, NRK, covered the report in their TV news, where this screenshot is from. A new UN report tells of an alarming consumption of the world's natural resources, tells the news reporter, with severe environmental consequences. The reportage continues with some good news. The report states that there is hope. The panel recommends a circular economy to reduce the need for resources. And change in our resource consumption is possible in a way that ensures good lives. Who is the International Resource Panel, also called the IRP? The panel links science and policy together on sustainable use of natural resources, including their environmental impacts over a full life cycle. The resource panel compiles existing knowledge from international research, somewhat similar to what UN's panel on climate change does and the International Panel on Biodiversity. The panel has about 40 experts from academic institutions and scientific disciplines across the world. Some of these experts are speaking here today from Norway, Finland, and Sweden. The panel's steering committee has representatives from 28 governments, the European Commission, and UN Environment Programme, which is also the Secretariat. I represent Norway in the steering committee of the resource panel. What does the resource panel mean by resources? Material resources include biomass, fossil fuels, metals, and non-metallic minerals such as gravel and sand. The concept of natural resources also include land and water, in addition to material resources. When communicating the key messages from the report, we sometimes just use the term resources to simplify the message. Increasing resource use is the main driver for climate change, pollution, and loss of biodiversity. Extraction and processing of material resources accounts for over 90% of impacts on land use-related biodiversity loss and water stress, over 55% of greenhouse gas emissions, and up to 40% of air pollution that might cause health problems. Material use has more than tripled over the last 50 years. Material use and its impacts continue to increase at a greater rate than increases in well-being. That's a paradox. In the figure, green shows biomass, purple is fossil fuels, black is metals, and blue is non-metallic minerals, such as gravel and sand. The built environment and mobility are the leading drivers of rising demand, followed by food and energy. Combined, these sectors account for about 90% of global material demand. The resource panel recommends resource-efficient measures and a transition to a circular economy. We will look at some examples from the report on possible solutions in the fields of the built environment, mobility, food, and energy. These topics will also be elaborated by the other speakers in the webinar. The report mentions several measures on resource efficiency and circularity in the built environment. Possible actions are resource-efficient and compact buildings, standards on low-emission materials and measures against material waste, and replacing cement and steel in buildings with wood from sustainable forestry. Going forward, we should restore existing buildings and reuse building materials rather than building new ones. Today's buildings can be seen as tomorrow's material banks. Furthermore, it is important to reduce the need for transport. This can be done by, for instance, offering good transport solutions and more efficient land use planning. Facilitating public transport, cycling, and walking rather than cars can reduce the need for resources in the transport sector. Electrification of vehicles will reduce greenhouse gas emissions. However, it will also increase the need for extraction of resources, such as minerals and metals. Today's production and consumption of food is not sustainable. The resource panel proposes measures such as dietary change, food with a smaller environmental footprint, for instance, less consumption of meat, and reduced food waste. It is also necessary to take care of topsoil that is suitable for sustainable food production. Energy is a big part of other supply systems. A resource-efficient energy sector also provides sustainability in the built environment, mobility, and food. There is a need to produce energy and materials without fossil fuels. A lot of energy is needed for both digitalization and electrification. The need for minerals and metals will increase in the years to come for renewable energy such as solar and wind power. Some challenges in the energy sectors are high demand for materials for renewable energy, storing electricity, for instance from solar and wind power, and competition for the use of biomass. Global Resources Outlook 2024 concludes that action is possible, but it is urgent. Please refer to the International Resource Panel and their reports in your work. Global Resources Outlook 2024 shows that it is possible to make the built environment, mobility, food, and energy more resource efficient and circular. This requires leaders across sectors, including government, business, and civil society, to act now. Let's bend the trend together to reduce resource consumption and take care of the environment and our well-being. Thank you.
Good morning. My name is Edgar Hertwig. I'm a professor at the Norwegian University of Science and Technology, where I teach industrial ecology. I've been with the resource panel since 2007. and I would like to talk you through what both how environmental impacts relate to resource use, and to talk a little bit more about resource efficiency in the built environment. Next. So this is one of the key figures from the summary for policymakers. It looks at environmental impacts and shows how different resource extraction and processing systems contribute to causing these environmental impacts. So the green part here relates to biomass production, so food and forestry products. We have metals, we have non-metal minerals, and then we have fossil resources. The blue part is the rest of the economy. So these are the emissions or resource impacts that are caused by further processing of materials or these other non-metallic, non-material resources. And then finally, the purple is households. We can see that especially for water stress and biodiversity loss, producing biomass is most important, whereas for other material, for other environmental issues, we can see that metal production and non-metallic mineral production and the production and delivery of fossil fuels are also important. As Marianne mentioned, together these cause a significant fraction of all environmental impacts. Next. So why are we using these resources? Well, we're using these resources to provide things that we need for our daily life, but also to build the infrastructure within which our daily life happens. And so resources are extracted and processed, and then they become part of these provisioning systems. And the provisioning systems that have been mentioned by Marianne, the food system, the built environment, the mobility system, and the energy system are really important. And they are important because they provide well-being. And as Janets mentioned in the introduction, in many parts of the world, the provisioning systems don't provide sufficient quality of food, sufficient shelter, sufficient mobility for the population. However, we live in a part of the world where such goods are provided in ample quantities. Next slide. Now, this is breaking out the environmental impacts not by resources, but by provisioning systems. So the food here is in this light blue shade, and again, this causes a lot of water, biodiversity, and biodiversity loss. In addition, it also employs a lot of people, mostly in farms in third world countries where agriculture is quite inefficient. Then we have the built environment. The built environment contributes importantly to climate impacts and also to air pollution, and household fuel use in yellow is most important cause of air pollution, and that mostly in developing countries related to the burning of wood and other informally collected materials. And then, of course, mobility is also quite important. Next slide. I would like to talk more specifically about what we can do to reduce environmental impacts in the built environment. This is an issue that Marianne has already mentioned. Parallel to the Global Resources Outlook, I contributed to producing these 3 reports that look more closely at the built environment in 3 emerging economies, Argentina, Indonesia, and Mexico. And next, I will use Indonesia as an example. Next slide. So what are the options to reduce greenhouse gas emissions and other environmental impacts from the built environment? This is now along the life cycle of the buildings. We can design buildings that just require less materials by using certain structural features or selecting materials that they are less heavy. We can substitute, as Marianne mentioned, concrete and steel or with biogenic materials. We can have higher yields, so have less waste on the construction site and more intensive use of materials. We can extend the lifetime of buildings by refurbishment instead of replacing the buildings. We can recover either components or materials and reuse those, or we can engage in recycling at the end of life. Next. Now, in the modeling in the Global Resources Outlook, one of the assumptions regarded the quantity of residential floor space that was demanded. This follows the example that we set with the resource efficiency and climate change report, namely that in the resource efficiency scenarios to the right, there's a lot less floor space demanded than in the baseline scenario. Next slide. And of course, related to material choices, related to material consumption, it's actually the form of the building is quite important. What we found is that medium-rise apartment buildings are most material efficient. Compared to that, both high-rise tower-shaped buildings and single-family buildings require more material per square meter living space. Next slide. As Marianne mentioned, we can reuse materials. I'm afraid on the left-hand side, I didn't have a slide from Jakarta and my visit there, but this is the reuse of beams in Norway. And on the right-hand side, we have the design of a traditional house in Indonesia from the Indonesian National Museum. And you can see it's all constructed of natural biogenic materials that store carbon instead of concrete and cement, which are the dominant building materials today in Indonesia. They cause a lot of greenhouse gas emissions in their production. Next slide. So we actually investigated different building designs and options to reduce both material use and greenhouse gas emissions from these different building types in Indonesia. Next slide. And what we found is that through these material efficiency measures, we could substantially reduce the cumulative greenhouse gas emissions that would be caused by future residential building construction. However, there is still a role for technology. So if you can decarbonize material production, there could be an even further rate of reduction in emissions associated with both with the expansion of living space and urban area in Indonesia. Next slide. So this is just an example of what can happen. A similar type of measures were implemented by the colleagues who did the modeling for the Global Resources Outlook. And this here is the sustainability transition scenario. And for the whole scenario, you can see to the left, the resource extraction that is required. And you can see non-metallic minerals in the middle is definitely flattening out. And the built environment to the right with the red bars is also flattening out. So we can see that this is a way, despite a growing population and growing area of housing provided to that population, there is actually a way to avoid increasing material use as much as it would be otherwise. And I haven't shown you the baseline scenario, but in the baseline scenario, material use would continue to rise. Next slide. So this is just to summarize. If we want to reduce environmental impacts from the built environment, we should assure that new buildings are sustainable in the way they are designed, but also in residential structures that are chosen that has implications for the urban form. If we have multifamily buildings instead of residential towers or single-family buildings, we can also have compact, livable cities, as the resource panel indicated in another report, the weight of cities. We would favor retrofitting the existing stock and reducing the rate of replacement, which is still quite high at this point, and to have a more intensive use of buildings, meaning that we would require less building space. With that, we can reduce the use of building materials in the building stock by 25%, energy use by 30%, and greenhouse gas emissions also by 30%. Next slide. And with that, I would like to thank you for your attention. Give the word over to my colleagues. Thank you.
Yes, thank you, Edgar. Thank you, everyone. And particularly thank you to Marian illustrating the big picture of the International Resource Panel's Global Resources Outlook Report. I am Eva Primer from the Finnish Environment Institute, and I will be talking a bit about the food systems, and I will do that with going through some of the key issues in the report, and then also sharing some aspects that my colleagues have worked on food systems transition in Finland. Next, please. So this figure you already saw, illustrating how biomass use actually generates much of biodiversity loss, both on land and in freshwater habitats. And also much of water stress and climate impacts are caused by biomass production. Next slide. And so when we think about biomass, this is a slide that Marian already showed, sort of drawing attention to the material resources. It's important that when we are thinking of biomass, we also consider land use and water use, because they are really connected to biomass production and really connected then to the impacts that biomass production generates. Next slide. And food is an important cause of biomass, or an important form of biomass use and land use. And this is just a set of illustrations showing again how biomass is important. So the green area in this is biomass use, and biodiversity loss includes also land use change and land use generated biodiversity loss. Next slide. So if we think about the food system, we might think about agriculture in the landscape of influencing the biodiversity and using fuel and generating carbon release in the landscape, so through agriculture. But it's important to consider the entire value chain via bioeconomy to the food on our plates. And this is what the International Resource Panel has done in the Global Resources Outlook, thinking of the entire system. And here on this slide, you already see some policy recommendations, but I will come back to them after a while, and Marian already hinted at some of those. So next slide, please. And like Edgar told you there, the idea is how the Global Resources Outlook looks at systems is that you have the ecosystems, the water ecosystems and fields where crops are farmed and where trees grow, and then the water ecosystems that are connected to the land. And you extract biomass for our consumption, for food, and this generates well-being by giving nutrition and also providing cultural well-being to us consuming food. And this kind of provisioning system approach is what the Global Resources Outlook takes. And like you see, the different sustainable development goals can be addressed by this systemic approach very well. Next slide, please. So the Global Resources Outlook importantly looks at resource flows between different areas of the world, and then how the impacts are generated in the different areas. And apologies for this illustration being quite small, but here you have first North America, then Europe, and we can zoom into Europe. And then on the top figure illustrates climate impacts, and the bottom figure illustrates biodiversity impacts. And so we can see that climate impacts are generated across the world because we have food production and food systems everywhere. Sorry, I was supposed to say that the blue is food, like in Edgar's presentation as well. So this is the food system impacts. Climate impacts are generated across the world, and the Latin America and Caribbean has a little bit higher than elsewhere impacts, and this is because of land use change and deforestation. On the bottom figure where you have biodiversity impacts, there's a couple of messages. One is that the Latin America and Caribbean are again really important in areas where these impacts happen. When we look at Europe and that area and generally across biodiversity impacts, the positive message is that the impacts are coming down, so there is less impact over time. Next slide. Here is another way to look at how the impacts are distributed across the world. Again, a really small figure that is difficult to look at, but the top is climate impacts and purple is Europe. So when we are in the Nordic seminar, it's good to think about how Europe generates impacts. So with everything that is under the under zero means that the impacts are exported, that we don't experience that proportion of the impacts in our area. So Europe exports much of its climate impacts. Similarly, the second row is biodiversity impacts. Europe exports biodiversity impacts. And then the bottom row is value added. And we can see that Europe generates value added within Europe. And so this just illustrates that the harmful impacts are exported and we are generating well-being in our own area. And if we think of food systems again, we can go to the next slide. It's important to remember that food is essential across the world, and we should have a very evenly distributed food system. This is from my colleagues' work who are working on food system transitions. And this is just an illustration of Finland's cropland needs across the world. So our tiny, less than 6 million population needs cropland all over the world. And this is the way we export our impacts to different parts of the world from the Nordic countries in general. Next slide. The Nordic countries are interesting. This is from another colleague's work. This is actually a report that just came out on material resource flow scenarios in Finland. But the message that I want to show with this is that Nordic countries also export resources. So we are not only importing resources, exporting impacts, and then generating value added here, but we are also extracting resources for exports. And for Finland, particularly biomass and non-metallic minerals are exported. So we also experience some of the environmental impacts here and then export them elsewhere. Now my screen went black, but I hope it's all working. Next slide, please. So this is from my colleagues' work who have looked at food system transition in Finland. And I took this slide just to show you how we could think about the systems in our lives here in the Nordic countries. So like I started with agriculture, so primary production, also primary production needs input. So in addition to bio-based inputs and labor, it needs fertilizers and fuel, so non-renewable resources. Then food is processed through manufacturing, and then it goes through retail to restaurants, canteens, and our tables. And all of these parts of the system play a really important role in how we think of food and what our food choices are, and how trends in food consumption change. And all of these parts also generate some waste. And the food loss is actually, food waste is actually an important message in the IRP report. This project that these illustrations come from has looked at fairness and justice implications in new food policies, and also how they are distributed. And next slide, please. So the work started around the time when climate policy was particularly coming to the different sectors, and really when we had stringent climate policies, they were generating new opportunities and very much changes in how agriculture and farmers were addressed in policy, and this resulted in distributive consequences, and also for all other actors like the restaurants and retail and food refinery businesses. The project also then looked at different other aspects of justice, so how the different actors are engaged and heard in the processes, and how they procedurally actually have a formal role in this kind of policy processes changing food systems, and how these changes in the policies could be buffered and corrected so that the changes for livelihoods and businesses would be manageable. So I want to thank my colleagues for these really interesting work that they have done in the food system transition. Next slide. I come back to the, no, maybe I still show this as a bridge from my colleagues' work who do a lot of important scientific baseline work, also look at collaborate internationally and look at biodiversity impacts, and then produce reports that can be used directly by decision makers. And this is exactly the type of work that the International Resource Panel builds on when we have done the Global Resources Outlook. And then we come back to the Global Resources Outlook messages. Next slide. So these are the messages, and we can look at the food system here. So that was demanding the reducing the demand for most impactful food commodities, and that is importantly, particularly meat. Reducing food waste, like I illustrated, that happens in the different parts of the chain, and protecting and restoring the productive land, so the entire large landscape that produces food. And if we do this, we can provide nutrition for everyone in the world and actually reduce land needed for food production. Next slide. The resource panel takes a broad approach to policy, looking at regulations, finance, trade, consumption, and circular economy importantly. And I was involved particularly in this part of the work, but Anders Wickman in his next presentation will actually detail a little bit more on these strategies, how to go ahead with reducing resource use. And next slide. So this is my final slide, and this is if you wanted to take a snapshot, here it is in a nutshell, or a potato. I took this message because in Finland last year we have renewed our sort of nutrition recommendations that are very science-based and health driven. But last year, for the first time, we included also environmental considerations in our nutrition recommendations. And the two small changes that this resulted in was even less consumption of red meat and more consumption of potato. And hence I take this potato picture here and want to thank you with that.
Dear friends, let me continue. My colleagues have already emphasized the serious shortcomings in the economic system that has been developed in and by the industrialized countries over, say, the last 100 to 150 years. As Janusz Potocznik said, and we seldom talk about it in this way, this system is wasteful and unjust. I need not dwell into the colonial period, but some of the components of that system are in fact still more or less in place. The architecture of the financial system, as well as of trade agreements and the intellectual property rights system, to a large extent benefit high-income countries. And that's a fact of life. So if we want to change the system, we have to start there. The economic system, with its focus on short-term profit maximization, and in a situation where market prices do not reflect the production costs, results in a situation where the well-being of future generations is at great risk. And as well, where the estimated 4 billion people who still live in poverty in different parts of the world today will have a very hard time catching up. Next slide. We need to change course. We need a pathway and a strategy which enhances well-being for people all over the world, not least in low-income countries. And at the same time, stabilizes the climate system and stops the further erosion of vital ecosystems. And in the panel's work, we have come to the conclusion that it is possible to change, but to make it happen, we need to focus on the main driver behind today's unsustainable development, and that is material consumption. Next slide. A key problem is that market signals do not encourage or stimulate the right kind of action. On the contrary, producers very seldom have to pay the price for destroying natural capital, meaning, as already mentioned, that market prices very rarely reflect the true cost of production. Both environment and social costs end up being paid by all of us, by society. And this means that market signals, as they are made up, regretfully make the situation increasingly worse. Next slide. And basically, our conclusion is that industrial or financial capital is overvalued, human capital is undervalued, and natural capital, unless it is traded on a market, is not valued at all. And ladies and gentlemen, this has to change. Next slide. So we have to transform the system. You have already seen this picture, and my colleagues have already given you examples from different provisioning systems what this could entail. So far, much of the focus in the societal debate has been on the supply side. And the objective has been to make production greener. And this is, of course, crucially important. But as we have tried to show already, it's not enough. We have to give priority as well to demand side, because demand, material consumption, is the main driver of both climate change, ecosystem decline, water stress, and biodiversity loss. And in the Global Resources Outlook 2024, we give a lot of priority to the demand side. And it concerns both consumption and consumption patterns, and indeed lifestyles. But, and this is, I think, even more important, to the consumption or provisioning systems and business models and how they are designed. The latter, in my opinion, is probably the biggest challenge. We focus mainly on buildings and infrastructure, mobility systems, food systems, and energy systems. But I think we should add that there are other important provisioning systems, like fast fashion, like electronics, where we also see a lot of problems in the sense that resources are used for only very short periods of time and not recycled and reused. There is a lot of waste going on. And in fact, we threw away a lot of money by doing it this way. Next slide. To bring about the much needed transformation, we will need action at several levels. Firstly, at the international level, and that will of course be difficult in a world where we have so much tension and even conflicts. But we have to look at international agreements pertaining to finance, trade, intellectual property rights, indicators and measurements. And from the panel's point of view, we would like to see in the future an international convention on the use of natural resources, because that would be much needed to really guide developments in the future. The second type of interventions and initiatives have to come at the national and or regional, in particular in the European context, regional level. Next slide, please. And if you look at this slide, you will see a number of possible initiatives to be taken. From our point of view, we would like to see the adoption of science targets or science-based targets for natural resource use. We are working on that in the International Resource Panel, but I would stress that we would need more backing from governments to make that happen. We need to rethink metrics for well-being, for performance, and the circular economy. GDP is not a good indicator for progress. Already Bobby Kennedy in 1968 showed in a speech a couple of weeks before he was shot and killed how poor GDP is as an indicator for societal progress. And Herman Daly, economist at the World Bank during many years, he stressed that there are, of course, good economic growth, but there is also non-economic growth that is not positive for society. So we need better indicators. We need also, in a situation where electrification is going to be increasingly important, we need to change the energy system from being heavily dependent on fossil fuels to being more electrified and based more on renewables. Will require a lot of metals, and for that to be possible, we need global sustainability standards to be developed for the mining and extractive sector. And we also need globally agreed standards and methods for tracing material value change and their impacts. I looked at some of the trade agreements struck by the European Union with third countries recently, and it's a fact that circularity is mentioned very, very rarely. So in order for this to happen, we need to include in the agreements standards for how to trace material value change. Another thing is also to help low-income countries to add more value to the materials extracted by them. It's a fact that 80 to 90% of materials exported from low-income countries have not been processed, meaning that value added happens in our part of the world and adds to our income and wealth. And of course, it should be the opposite. And here, high-income countries, the world community, has to help bring about the necessary change. We have also to sensitize the international community to the need to allocate significant more financial resources to resource efficiency measures. This is an area that has been neglected most of the time. If we look at efficiency when it comes to labor or even energy, efficiency measures have been forthcoming over the years quite nicely. But when it comes to materials, there has been very little focus on that. And this is, of course, something for national governments, but also for the international community. And then finally, and I'll come back to that, we have, of course, to internalize the true costs of both material production and consumption. As I already indicated, market prices do not reflect the externalities, meaning that we don't pay for them. So I already have the next slide up. When you look at, no, that's it, yes. No, please go back. When we focus on what a national government can do, we have to start with market prices and that they have to reflect the true costs of production. And here we are suggesting resource taxes, ideally through a tax shift, lowering taxes on labor and increasing taxes on the use of nature. It's a mystery to me that not more has been happening in this area. Our former co-chair of the panel, Ernst von Weizsäcker, wrote a book about this, ecological tax reform, 35 years ago, but it's still long in the making. We also, of course, look at carbon taxes. Most countries in the world don't apply carbon taxation. It could be done in many different ways, but it's necessary. One interesting idea is, of course, the system with a carbon fee and dividend, where the revenues from carbon taxes are being distributed equally to the population of a country. That would be a way that would benefit, in particular, low-income takers. We need to invest much more heavily in resource efficiency from the point of view of innovation. So science and innovation policies have to give much greater focus and priority to this, and national governments have an important role to play. We need incentives to speed up the pace of electrification, priority given both to renewable technologies, but also to storage technology. But it has to be done hand in hand with energy efficiency measures. This is necessary to curb pollution, but also to avoid scarcity of metals like cobalt, lithium, etc. It takes a long time to open new mines. And even if we don't see in the near term scarcity as a main problem in terms of the Earth's crust of different metals, we are conscious of the fact that unless we are more efficient in the use of energy and electricity in the future, it's going to be difficult to provide the necessary supplies. By the way, efficiency in this sector is, of course, also part of our overall message that materials, including energy, have to be, or resources, including energy, have to be much, much more efficient and intelligent in their use. I already alluded to indicators. Here they come again. GDP is one area, moving from GDP to well-being indicators, which would then really tell a country real progress. But we also need new indicators with regard to the circular economy. For instance, we need to distinguish or be able to distinguish between stocks and flows of materials. We cannot do that today. When we extend the product life of products, we have to be able to measure that, because that's an important component or element in a circular economy policy. We have to regulate marketing practices to curb waste and overconsumption. This is going to be very, very difficult and challenging. And I think it's very much linked to what kind of business models that are being developed in the future, because business models could be more responsible. Fast fashion, for instance, is one example where the business model is not responsible, where we waste a lot of materials simply because of the way the business model is designed. And finally, we have to align trade agreements, as I said, with the objectives of the circular economy. And one important thing that we often overlook is we have to deal with the so-called rebound effect. When we make systems more productive, we free up resources. And there is often a tendency that those resources will be used to demand more energy and materials somewhere else in the economy. So that has to be countered by, for instance, taxes. Next slide. I've come to the end. This slide you have already seen before. It just illustrates that in our scenario work, we have come to the conclusion that by introducing some of the policy measures and some of the other measures that my colleagues have talked about, building design, food system design, etc., it is indeed possible to lower the use of natural resources. And we need not end up where the business as usual scenario would end up with a 60 to 70% increase in natural resource use by 2060. So that gives hope. We are conscious of the fact that we need a lot of more research, we need a lot of more innovation, but we believe that the Global Resources Outlook 2024 gives a very good platform for discussions on these important issues. And I would end by saying that I think Janusz Potocznik was very right in his comment across the end of his intervention. The future will be green, or there will be no future. Thank you very much.
So in this webinar, you have received the main messages of Global Resource Outlook 2024 on how to deal with increasing resource use. If you want to return to these messages, the recording will be made available on the Norwegian Environment Agency's website. I would like to thank Janusz, Marianne, Edgar, Eva, and Anders for their participation. And I would also like to thank you, the audience, for listening and showing interest in this important topic. Let's now close this webinar and instead move to action. Goodbye.